Have you ever wondered what it would be like if you could teleport? Imagine the possibilities. No more sitting in traffic, no more long-haul flights. You could be in Paris for breakfast, New York for lunch, and Tokyo for dinner. Teleportation, this mesmerizing concept of instantaneously moving from one location to another, has been a staple of science fiction and fantasy for years. It's a concept that has captured our collective imaginations and has found its way into some of our favorite stories. Who hasn't been captivated by the teleporting antics of the crew in Star Trek, or the magical apparition of wizards in Harry Potter? This idea, as fantastical and far-fetched as it might seem, is an integral part of our culture, stimulating our curiosity and provoking our sense of wonder. But could teleportation ever become a reality? Let's delve into the science. Teleportation, as we know it, originates from the realm of fiction. This fascinating concept first made its appearance in the literary world in the late 19th century. Edward Page Mitchell, an American author, introduced it in his short story, The Man Without a Body, published in 1877. Since then, teleportation has become a staple in the genre of science fiction, capturing the imaginations of readers and viewers alike. From the iconic Beam Me Up Scotty in Star Trek to the Flu Network in the Harry Potter series, teleportation has been depicted in countless ways, each more intriguing than the last. These portrayals have sparked countless conversations and debates, reinforcing teleportation's status as a product of human imagination. Despite its roots in the world of fiction, one can't help but wonder, could there be a scientific basis for teleportation? Could the dream of instant travel become a reality? It's time to explore. Science has always been inspired by fiction, and teleportation is no exception. Now let's delve into the science behind teleportation, specifically the concepts of quantum teleportation and quantum entanglement. Quantum teleportation, as the name suggests, is a phenomenon that occurs at the quantum level. In simple terms, it's the transfer of quantum information from one particle to another, regardless of the distance between them. This is achieved without any particle physically traveling the distance, hence the term teleportation. But it's important to remember that quantum teleportation is about information, not matter. It's like sending a fax rather than physically sending the document. Then there's quantum entanglement, a fascinating and perplexing concept. It's a bond that forms between two particles, tying their states together. So when something happens to one particle, the other instantly feels it, no matter how far apart they are. Imagine having a pair of dice that are always guaranteed to land on the same number, even if one is in New York and the other in Tokyo. That's quantum entanglement. These concepts are mind-boggling and fascinating, but how do they tie into teleportation? Well, if we could manipulate quantum entanglement to transmit the quantum state of every particle in an object, like say, a human, to another location, we would essentially be achieving teleportation. But remember, we're talking about a mind-numbingly large number of particles here. The human body, for instance, contains roughly 7 octillion atoms. It's a tall order, and we're currently far from applying these concepts to teleport humans or large objects. The most we've managed so far is teleporting information about a particle of light a few miles. Moreover, there's the issue of the original copy. In the process of quantum teleportation, the original state is destroyed, raising a multitude of philosophical and ethical questions. So, while we may not be able to teleport just yet, who knows what the future holds? As we gaze into the future, the possibilities of teleportation continue to tantalize us. The potential implications of teleportation are vast and varied. On the positive side, it could revolutionize travel, making it instantaneous and eliminating the need for traditional transportation. Imagine, no more long flights or time-consuming commutes. Beyond travel, it could also transform how we communicate, making physical distance irrelevant and bringing people closer together than ever before. But, like any scientific advancement, teleportation also holds potential drawbacks. Privacy and security concerns are paramount. Could you imagine the potential for misuse if someone could simply teleport into your home unannounced? Moreover, legal and ethical questions about teleportation would need to be addressed. Who would have access to this technology? Would it be regulated, and if so, by whom? Teleportation, once a figment of our imagination, has now become a tantalizing prospect for the future. The journey from fiction to reality is always an exciting one, and who knows where it might lead us next.